What's up, kids? This is Algebra 2.1. I'm Mr. Carlson with C-Squared Mathematics, and this is the last week before we actually finish our Unit 2, Complex Numbers and Rational Expressions. So we have 2 more lessons to get through this week, and then we'll take the test. The first of those lessons is what we call radical equations. So we're not going to get rid of the radicals as of yet. We're still going to be working some math on it, and we're going to put equations around these radicals, or rather radicals around equations. So I'm going to go through a couple of examples just to see what those look like, and we're going to be using a lot of squares, a lot of square roots, obviously, and it's just a really fun time. And then we're going to go through checking them as well. So bell work, and then the lesson, closure and summary afterwards. To kind of review from last week, this is what I'm going to go through. I'm going to go through these 2 questions, rational exponents. This was our last lesson of last week, so let's get started on them. Feel free to pause the video at any time. So right here, we have 625 in parentheses times x to the 12th times y to the 16th, all to the power of 1/4. Now remember, 1/4, if I have x to the 1/4, just remember this. This means my 4 is my index, okay? And then that 1 is my exponent within that radical. So this right here, that 1 is what we call the exponent, and that 4 is what we call the index. So just remember that. That's from last week. I hope that makes sense. If I have x to the 3 all over 4, what this means is my 4 is still the index of my radical, but then I have x cubed, okay? Or I could write it as this, okay? So 4 is my index, and then cubed. I can write it either way. It just depends on what I want to solve for, okay? So that's sort of a review from last week. So what do we do here? Well, remember, this is what we call the power to a power rule. Because I have powers here, even right here, the 625 is the power of 1. So that means I have to take this 1/4 and distribute it to all the other existing powers within my parentheses. So what does that look like? That looks like this, 625 to the power of 1/4. Now why is that? Because 1/4 times 1 right here. Okay, 1/4 times 1 is just 1/4. Now we multiply them. So times x to the 12th, it's going to look something like this. I'm going to put parentheses around it, to the 1/4 power. That's what it's going to look like. And then times y to the 16th to the 1/4 power. That's also what it's going to look like. So we can start simplifying this. So for instance, 625, I already to the 1/4 power is the same thing as the 4th root of 625. And that right there is just 5, okay? And I can plug that into Desmos if I wanted to. I'm not going to show that to you, but you can absolutely do that. We also wrote that down as one of our common higher roots last week during the higher roots lesson. Now right here, what we have is 12 times 1/4. So these are multiplications, okay? 12 times 1/4. So that means I have x, and then 12 times 1/4 is literally just 12 divided by 4. And same thing here, 16 times 1/4. And that's the same thing as y to the 16th power all over 4, okay? So as I simplify this, this is 5, and then 12 divided by 4 is just 3, or cubed, and then 16 divided by 4 is just 4, so y to the 4th. So this is my final answer, okay? Again, just review from last week, but I hope that helps. I hope that helps you understand that I multiply these exponents here because it's what we call a power to a power. Okay, that's an actual exponential rule that you learned in Algebra 1. So right here, what do I have to do? Well, I do something different. Well, first of all, I have to notice that this 5 and this 4 can be multiplied because this is multiplication. So I'm going to do that. I'm going to do 20 and then times x to the something power. What is that something power? Well, here it's a little bit different because now it's not a power to a power, but it's a product to a power. So it's product of a power. So that means I don't multiply them. What I do is actually add them. I have to add these 2 exponents together. So I'm going to do that off to the side here. I'm going to take 1/2 plus 1/5. Now, the reason why I can do this is because they are the same base, which is x. Okay, so if they were not the same base, then I wouldn't be able to do that. But since they are, this is x and x, I can absolutely add these exponents because they are the same base. Now, the numbers are just the coefficients. I can just multiply those just straight up like normal. In order to do this, I do need to find a common denominator. The common denominator, if you don't know, just multiply the two denominators together, and that will be 10. And it just so happens that's our least common denominator. So times 2 gives me 10. 1 times 2 gives me 2. 2 times 5 gives me 10. And then 1 times 5 gives me 5. So now what I have is 5 all over 10 plus 2 all over 10. Now I can actually add these, so this becomes 7 all over 10. So this right here is not my answer, but it is my exponent, and that's exactly what I'm going to do right here. I am going to put that as my exponent, so this is 7 all over 10, right on my x. That's my final answer. Okay? So, review from last week. I hope that helps. Let's get started on the actual notes. I'm going to erase this. All right, so objective. I can solve equations with radicals by reviewing Algebra 1 concepts of radicals and applying new Algebra 2 skills. So I'm going to show you what those skills are in a little bit. And then my essential question is, how do I solve equations involving radicals? What's the basic steps for it? But not just that. How can I actually mimic the strategy behind solving these? Because there is a slight strategy that we need to understand before we actually attempt these problems. Okay? And so I'm going to give you the steps for some of the basic ones. And of course, these are going to get harder as we go on. I'm probably going to have maybe 7 of these examples, and then we'll see how it goes from there. So the first thing is we want to isolate the radical. That's probably the most important thing. Notice how I'm not saying isolate the x. Okay, I'm saying isolate the radical. If you remember from absolute value equations, the first week of Algebra 2.1, we said isolate the absolute value part, right? We didn't say isolate the radical. We didn't say isolate the x. We said isolate the absolute value part because the x is within the absolute value part. So we have to isolate that. Just similarly, we have to isolate the radical part, okay, not the x. And I'll show you what that means in a bit. Square both sides. Why? Because this is the thing that we need to understand. If I have a square root of x, I need to square, and this is, let's just say this is 1, I need to square both sides, so that square and this square root, notice how I'm kind of canceling the square root here, not the x, so that it goes poofy and I have x equals, of course, 1 squared is just 1. Okay, that's a very basic example, but it suffices, it is sufficient to teach us exactly what the general process we are going to be utilizing here. And that is the inverses of square and square roots. They are inverses. Remember during our Desmos activity, our intro to inverse functions, Desmos activity, that's most of you completed. Not all of you, but some of you. Okay, most of you completed. Remember, we had some questions on there involving the inverse. The square of x is the inverse of the square root of x. They outdo each other. They undo each other. Okay? Just like if I tie my shoes and then I untie my shoes. They are undoing each other. So if I take the square root here, I get x. But if I take the square here, I get x. Okay, notice how they undo each other to get just x. And the exact same thing that we're going to be utilizing here, we're going to be using the inverse properties. So that's the basic strategy we're going to be utilizing when solving or squaring both of these sides. We're going to solve the remaining equation, so that's when we actually solve for x. And of course, we want to check. Now, this is a very important thing. Normally, when I would say check in like lowercase letters, and I would say, yeah, we should check it, but if you did it right, then there's no problem. However, in this case, we do really have to check. Now, why is that, Mr. Carlson? Great question, kids. Because when you take a square of something, what you're doing is you're trying to unveil or unravel. I think unveil. Yeah, unveil. How about that? Unveil. You're trying to unveil some of what we call the extraneous solutions. And those are solutions that show up but are not necessarily part of my actual solution set. So they could actually not be a solution, meaning they don't cross the x-axis. Okay? And that's an issue, right? That's a horrible issue that we need to understand. Okay? Awesome. Okay, let's get into our first question. Very simple. Find the real solutions of the equation. Now, they say real because we don't want imaginary, right? We don't want imaginary solutions to this. We want the real solution. So how do I go about solving this? Well, first of all, is it isolated? Is this radical part completely and utterly by itself on one side of the equation? And we can say, yes, it is. It is radical 24 minus 5 all underneath the equation, or all underneath the radical, and it's on one specific side, where everything else, this random x, is on the other side. Now we want to square both sides. So now that one is done, let's go to squaring both sides. What's going to happen here is this square root and the square goes poofy, so I'm left with 24 minus 5x equals x squared. Now what we want to do, since we solved that, I want to solve the remaining equation. So how do I solve the remaining equation? Well, you have a square here, and so if you should know, you should be able to recognize this, that this looks extremely similar to a quadratic. Extremely similar to a quadratic equation. So what I'm going to do is I'm going to actually move all this stuff over, the 24 and the negative 5x, over to the right side of the equation, so I can get x squared positive and 0. I'm going to set it equal to 0 on the left side. The reason why I want to do that is so that I can actually solve for x. So now it's going to become positive 5x and then minus 24. So now what I can do is I'm just going to solve it like my normal quadratic equations. I have my template here. This is my basic template, x, x. And now what we're going to be asking is, if you remember, what are factors of negative 24 that somehow, some way add up to 5? Factors of negative 24. I'm going to get man, this arrow is not cooperating with me. I want to make a good arrow. Okay. Factors of, there we go. Factors of negative 24 that somehow, some way add up to 5. There should be a very simple one here. There's only really 12, 2. You have 6 and 4, but you also have 24 and 1. But primarily you have 8 and 3. Now, if you have 8 and 3, somehow, some way, they do add up to 5, and that's if we put the negative with the 3. So 8 minus 3 does give me positive 5. Now, it doesn't matter where I put the positive 8 or the minus 3 here. No. So I'm just going to put the positive 8 here and then the minus 3 here. Factors of negative 24 that when multiplied give me negative 24, but when they add together, they also give me positive 5. And that's what I have. Now, of course, I can set each one of these equal to 0. So x plus 8 equals 0, and then x minus 3 equals 0. So that means x equals negative 8, and then x equals positive 3. Now, this is all fun and dandy and great. However, we still have one more thing we need to do, and that is check. We need to check each solution, okay, to see if it's actually true. So that means let's start with negative 8 first. Let's actually plug in negative 8 into my original equation here. So 24 minus 5 times negative 8, and then equals negative 8. So what this means, guys, is I'm only taking what's in black here. I'm not taking like the red square or anything. I'm just taking my original equation and I'm plugging it in. Now, if the left side equals negative 8, then it's true. It's a true equation. That means it's a true solution. But if it doesn't, then we have to get rid of it. We have to cancel it out. It's what we call an extraneous solution. You need to do this. It's not an option. Okay? So let's start going through it. This is 24, and then plus 40, because 5 times 8 is 40, and this is negative 8. 40 plus 24 is 64, and this is negative 8. And this is actually 8 equals negative 8. Now, if some of you are maybe wondering, well, if you have the square root, isn't that just plus or minus? No. You only have a plus or minus solution if you take the square root of one side when it wasn't already originally a square root. Here, it's already an original square root. We didn't take the square root of either side. So in this case, since it's technically an expression as well on one side, the left side, it's what we call just the positive root. We only take the positive root here. But here, it presents a problem. Is positive 8 actually equal to negative 8? No, which means since it's not, this cannot be a solution. Negative 8 is not a solution. So now let's go to our other one. Let's type in 3. So 24 minus 5 times 3 and then equals 3. We're going to put in 3 now because, again, my x, we said x is 3. We're going to put in 3 right there. So what do I have? I have 24 and then minus 15 equals 3. And then what's 24 minus 15? Well, that's 9. So I have square root of 9 equals 3. And the square root of 9 actually does equal 3. So does this check out? It does. So that means my final answer is what I'm highlighting here in green with a smiley face. It is only 3. Okay? So that is the basics of radical equations. Now I'm going to show you a slight trick. This doesn't always work, but most of the time it does, especially if you don't have fractions involved. We can use Desmos. I'm not going to show you how to use Desmos on every single one here, but I will show you maybe on like 2 of the examples that we do, just in case you can utilize it, just to make sure you do have the right answer. So what I'm going to do is I'm actually going to erase this. I'm going to actually put this, our original problem here, I'm going to put our original problem straight up into Desmos. I'm going to show you that it does get the exact same answer that we wanted, which is 3. So let's do that, okay? Because 3 is our answer. So I go over here and I actually type this in. I type in the square root of 24 minus 5x. Now you'll start to see a lot of stuff happening here. Now, it did say equals x. Now this kind of seems weird, and this is the problem. We probably shouldn't do this. To actually make it look a lot neater, what we can do is equal it to 0. So instead of just saying this x on the right side of the equation, we can subtract it over to combine with my square root, which means it would look something like this. If I erase this, if I actually do minus x, because it was a positive x on the right side, and then equals 0, what we get is a truer equation. Now, you may say, well, that's exactly what we got before, and it is. It is. It's just a random straight line. So what we can just do is get rid of the equal 0, and we actually get a true radical graph, because this is what a radical does look like. Okay, this is what a radical graph does look like, okay? So what does that mean for us? It means this. That's my answer. We got x equals 3. Notice how we had 2 answers. We had negative 8 and then x equals 3 on the last slide, right? And what we did was we checked it and we said, well, negative 8 can't be a solution. It is only positive 3 to be a solution once we checked it. But you can also check with Desmos. Okay, as long as you actually subtract that x over. Okay, now you could do it like this. This is our original equation. Now you could just zoom up and it's very clearly 3 right here. Obvious, like that's all you really needed to do. But some students just like to make sure they can actually click on the intersection here, because that's really what we're trying to find. We're trying to find where this graph, this radical graph, because it is a graph, where it actually hits the x-axis. Okay, so some students like doing that, but some students just like to take that positive x and just subtract it over to the left side of the equation. They can even say equals 0, or you can get rid of the equal 0, and it's very obvious that it crosses your x-axis at that point, 3, 0, where my x is 3, but my y is 0. But that's okay because all I need is the x. So when we're solving something, what we're trying to do is solve where the graph hits the x-axis. So this whole lesson, could you honestly do this on Desmos? Yeah, okay? Some of them are a little bit tricky because we will get fractions involved and stuff like that, or no solutions or whatever, okay? And I'll kind of guide you through that. However, the vast majority of these questions can be solved using Desmos because graphically, this equation can be solved using a graph or just using straight algebra. Now, I'm going to show you the algebra throughout the rest of the slides. I'll maybe show you one other example where I can show you how to do on Desmos, but the vast majority of them will be using algebra. Fantastic. Let's get started on this one. So, is the radical isolated? Yes, it is. It's on the left side. I'm going to do this a little bit faster here. So that means I'm going to square this whole thing, but I'm also going to square this whole thing. Notice how I put this in parentheses, and you must do the exact same thing. Put it in parentheses, which means this square and that square root goes poofy, so I'm left with x plus 8 equals, and then I have x minus 4 squared. So now what I'm going to do, after I squared both sides, I'm going to actually solve the equation. How do I solve it? Well, the left side is chilling right now. I'm not going to do anything with that. I need to actually simplify the right side. And since it's square, that means double of. So I'm going to make sure it's double of that. What does that mean? Well, when we start simplifying this out, I have to FOIL. So the first is x times x, which is x squared. This is x times negative 4, so negative 4x, negative 4x. And then right here is positive 16. So this actually simplifies down to x squared minus, when I add those up, negative 8x, and then plus 16. Now on the other side, what I have is x plus 8, because that just hasn't changed at all. It's just been chilling. So now what I'm going to do is I notice that it's a quadratic. Okay, it looks similar like a quadratic. So that means, that shouldn't surprise us, right? Because we just undid the radical, which means if I undo a radical, I always will get a quadratic, which means I have to solve it like a quadratic, which means I have to take both of these things and subtract them over. So I have 0 equals x squared. When I subtract the x over, I get negative 9x because it will have a negative x right here. Negative 1x minus 8x is negative 9x. When I subtract the 8 over, 16 minus 8 is just positive 8. Now, what are factors of 8 that somehow, some way add up to negative 9? There's a couple of them. So let's do, well, there's actually one of them. Let's do my basic template. Since this right here, notice, since this right here is positive, I then look at my sign right here. By the way, this is review from Algebra 1. This is not Algebra 2 stuff, what I'm doing right here. I already did the Algebra 2 stuff by doing the square root. Everything else is Algebra 1. So right here, when I look at that sign, it's positive. I look at the next sign, that's negative, which means this tells me both of them have to be negative. Okay? If this sign was negative and that was positive, be negative slash positive. Negative or positive. If this was negative and a negative, both negative, or sorry, one negative, one positive. If this was a positive and that's a positive, that's only when it's both positive. So it's sort of confusing, but it takes getting used to, okay? So now, what do I have? Factors of negative, or positive 8. Factors of positive 8 are just 8 and 1. I can have 4 and 2 and all that fun jazz, but those don't add up to 9. How can this add up to 9? Well, it can add up to 9 using a positive 1 or a positive 8. But the problem is we don't have a positive 8 or a positive 1. So I need a negative 8 and a negative 1 and so forth. So that's what I have. And they both add up to 9. Negative 9. Okay? So when I FOIL this out, if I wanted to FOIL this out, I would get this back. That's how you can check it. Okay? If I FOIL this out, I should get that back out. I encourage you, if you don't trust the math, do it. Do that. Go through that as well. So now what I have is x equals 8 and then positive 1. Now usually what we would do is do what we call the zero product property, and we would say x minus 8 equals 0 off to the side. So x minus 8 equals 0. We would also have x minus 1 equals 0, and then we would solve for that way. I'm probably going to skip that small step for the next couple slides just to save time. Now remember, I don't know if those are my actual answers, so we do need to check. So let's check it out. I'm going to plug in 8 first. Let's see if it actually works. So radical 8, then plus 8. I'm plugging 8 for x here and 8 for x there. This equals, now remember, they didn't have any of the squared part here. Okay, so it's just that. So I should have each side equaling to each other. So 8 and then minus 4. So this is going to be radical 16 equals 4. Radical 16 is 4, and then 4, this checks out. So that means 8 is one of my answers. Fantastic. What about 1? Okay, so if I put in 1, so 1 plus 8 equals 1 minus 4, because 1 is going to be right here and right here. Just substitute 1 in for x. 1 right there, 1 right there. Just like what I have here. And this is going to be radical 9, and then equals negative 3. And then this is going to be a positive 3 equals negative 3. Now the problem with this is, does that equal? No. Okay, positive 3 does not equal negative 3, so that can't be a solution. So that means 1 is not a solution. What's my actual solution? 8. Okay, smiley face. 8 is my only solution. Fantastic. Now, I'm going to show you how to do that on Desmos as well. Okay, I'm going to show you how to plug this into Desmos, and so you can check to see if you can get the right answer. But this is the last one I'm actually going to do plugging to Desmos, because I feel like it's way more beneficial for SATs, ACTs, and I feel like it's more beneficial just to stretch your mind and use Desmos as a last-minute resort, not to always go to Desmos and plug it in. But I'm still going to show you how to do it because I still think it's neat. So I know 8's my answer. Let's go to Desmos and plug that in. Okay, so my original thing was square root of x plus 8. This was equal, and then x minus 4. So that's really what I had. If we zoom out here, I get that. Now, that's a random line. Of course, it hits 8. To see it a little bit more clearly as an actual radical, I need to subtract these over. So let's do square root of x plus 8. What I need to do is subtract the x over and then add the 4 over. So then it equals 0. Now, I don't want equals 0. Okay, so what I'd rather do is just get rid of the equal 0, and this is really what I have. Okay, so here it's very clearly seen that 8 is my x. Right, so that's how you solve it using Desmos.com. This is the last time I'm going to show you using Desmos. The rest of the examples I'm just going to go to town on, just going super fast. All right, and hopefully you can follow along. But if you don't know what's happening, just comment below in the comments on YouTube, and then just ask or just email me separately. Awesome. Let's erase this and let's move on. So this is the next example I'm going to do. I want to see if you guys can actually do this by yourself. So go ahead and pause the video because it's very similar to the last example that we did. Go ahead, pause the video, and then when you come back, I'll have the answers there for you. Pause the video. Really do. Try it. Try it yourself. Check it. Check it yourself. See if you can do it by yourself. Okay? All right. Welcome back. So this is all the stuff that we did. You should have done by yourself. So first thing, I recognize that it is isolated. So I squared both sides. I got 2x plus 17 equals. Squared means double, so I double that, which means I have to FOIL. That's what you see in red. So the left side is just going to be chilling for a while. So as I'm foiling it out, I get x squared plus 7x plus 7x plus 49. I add the 7x's together to get 14x. And then what I do is I subtract the 17 over, subtract the 2x over. If I subtract the 2x over, 14 minus 2x is 12x. And then 49 minus 17x, because I'm subtracting them over to the right side, I get 32. The reason why I do that is because I recognize that the inverse of a radical is a quadratic, which I have, and I need to solve it accordingly. How do I solve quadratics? I have to set it equal to 0 on one side it's easier to subtract the 2x and the 17 over on the right side and to get 0 on the left side. So that's what I did. So I got x squared plus 12x plus 32. What are factors of 32 that somehow, some way add up to 12? 8 and 4. That adds up to 12. Both positive signs. So that means both of them are going to be positive here. So I get, after I do what we call the zero product property, I switch the signs. X equals negative 8, x equals negative 4. What do? Well, I have to check both of them. So once I check negative 8, I plug it into the original. I actually get 1 equals negative 1. So that means I can't have negative 8. And then if I plug negative 4 in, I actually get 3 equals 3. So therefore, it does work out. What's my actual answer? Negative 4. Okay, so if you got that correct, fantastic job. Let's move on to the next one. Pause the screen if you need to get those notes down. Okay, this next one, it's a little bit different only because it's not isolated. So what do we need to do first? We do need to isolate that. So I'm going to take 2x and then plus 19. And then once I isolate that, I'm going to add the 8 over. So this is x plus 8. And now it's literally exactly like before. I can square this. I can square this. I am going to be skipping some steps in this. So this is going to be 2x and then plus 19. When I square this, this actually equals x squared and then plus 16x and then plus 64. That's what that will be. Okay, when I square the whole thing. Okay, remember what this means is x plus 8 and then times x plus 8. Okay, and that's what I get there. So now I have to subtract that stuff over. So this is equals, 0 equals x squared. Subtract the 2x over, so that's plus 14x. And then when I subtract the 19 over, I get 45. So this equals 0. Factors of 45 that somehow, some way help me solve this quadratic to equal the middle, and that's just 9 and 5. So plus 9 and then x plus 5. So 9 plus 5 give me 14, but 9 times 5 gives me 45. So that means x equals negative 9 and negative 5. Now, for the sake of time, I'm going to actually just allow you to check it yourself. I'm not going to check it for you. But after you check it, after you plug these values in, you actually get negative 9 to be an extraneous solution. Okay? In fact, I'll just show you it real quick right here. All right, so that's how you would check it. I'm not going to go through that. I've explained how to check it many, many times. So go ahead and take a screenshot or pause the video, get that down. But you basically check it like normal, and then you find that negative 9 is an extraneous solution. Negative 5 is my actual solution. You could technically plug it on Desmos as well. Let's go on to the next example. All right, so this one is a little bit different only because you only see how it's different because it has a lot of extra stuff here. But the first thing I'm going to do is subtract the 8 over. So this is 2x, and then this equals, when I subtract the 8 over, I have x and then minus 4. Now what I can do is square both sides. To square and that goes poofy. I have 2x equals, this becomes, I'm actually going to FOIL this all out, all in one sweep, x squared. And then this is going to be minus 8x and then plus 16. Subtract the 2x over, so this is 0 equals x squared minus 10x and then plus 16. Factors of 16 that somehow, some way add up to negative 10, and that's going to be 8 and 2. So x minus 8 and then x minus 2. And this becomes x equals positive 8 and positive 2. Okay, so the check. This is the check. I just plug it in like normal. For 8, I get 12 equals 12. For positive 2, I get 10 equals 12, so that can't be it. My actual answer is 8. Solid. We're going to town on these. Let's go through a couple more. I think maybe just one more, and then we will be solid. So this one is a little bit trickier. You will see this something like this on the homework quiz. Okay, the reason what makes it tricky is because you have two radicals. However, we still want to solve it like normal, so I'm going to teach you how to do that. What do I do when I have two radicals? Well, the first thing is I'm going to isolate one of them on, let's just say, the left side, which means I'm going to actually take this radical and move it over. So what I have is radical x and then equals, equals, and then I have 1 minus radical and then x minus 7. That's what I would have. Now when I have this, I can just solve it like normal. I can square both sides. Now, as you can imagine, this kind of will get sticky. Okay, it'll be very messy here because what's going to happen on this right side? You're going to have to FOIL this baby out. Now, of course, the left side it goes poofy, and you're just left with x. That's nice, right? But this side, what you actually get is 1 minus the square root of x minus 7, and then times 1 minus the square root of x minus 7. So you get this whole monstrosity, and yes, you do have to FOIL it out, which is what makes this one so difficult. So again, I'm going to just reiterate what we did was when we had two radicals, I have to take one of them and subtract it over to the other side. I have to be able to separate them so that when I square, I can actually eliminate certain things. I'm going to show you what that means in a little bit. So when I actually FOIL this out, I take 1 times 1 is 1. This is just the exact same thing because it's just times 1. This is the exact same thing because it's just times 1 here. And then this right here, what's a radical times a radical, especially when it has the exact same base, minus x minus 7. Okay, if we took radical 2 times radical 2, it is 2. If we took radical 3 times radical 3, it is 3. So what happens when I take radical x minus 7 times radical x minus 7? It should be x minus 7, the exact same thing. It is that base, right? So that's what I'm going to do. A negative times a negative gives me a positive, and then I have x minus 7 here. So x and then minus 7. Now technically this would be in parentheses, but it doesn't really matter because it's a positive. So now when I actually start, and the x is chilling here, when I actually start simplifying this, what's going to happen is this. I can combine these two things. Let's do it in red here. I can combine these two things because they both have a coefficient of 1. And then I can also see this negative 7 on that side, and then the 1 here I can combine. But also notice this. I'm going to do one more thing. The x is on the left side, and an x is also on the right side. What happens when I subtract those? If you have the exact same thing on the left side as you do on the right side, the exact same sign, the exact same coefficient, the exact same variable, what happens is these actually go poofy. So right here, it's actually not just x, it is just 0. Those go poofy. So I'm doing a lot of work all in one sitting. So try to pay very close attention to what I'm about to do here, okay? Ready? So what I have so far is 1 minus 7, which is negative 6. Okay, those are done. And then what's negative 1 minus 1? Well, that's negative 2. And then I have a radical x minus 7. I'm almost going to treat that like a variable. Now, what happens when I do this? How can I actually solve this? Well, I'm actually going to add that 6 over because I want to isolate the variable. I want to isolate the radical part again. So I'm going to do the whole process over again where I only have one radical. I'm going to try to isolate that radical. So now I have 6 equals negative 2 and then radical x minus 7. I'm going to divide by negative 2 so I can isolate it. So I'm going to continue the work all the way up here. So this is going to be negative 3 equals, that went poofy. And so now what I'm left with is radical x minus 7. What am I going to do now? Well, just like in our steps, I'm going to square both sides. So I'm going to square that side. Those go poofy. This becomes actually, because in parentheses, make sure you put your parentheses around it. I'm squaring the whole thing, not just the 3, but the negative as well, which means this becomes 9. And now this will become x minus 7. Okay? When I add the 7 over, I get x equals 16. Not too bad. Not too bad, right? One last thing we need to check. Okay, you have to check it. You have to. Okay, it's not an option, all right? You have to actually check it. So what happens if I plug 16 into my original equation right here in black? I have radical 16 plus radical 16 minus 7 equals 1. This is going to be 4, and then plus this right here is just 9, so radical 9 equals 1. And as you can probably tell, is that going to equal the exact same thing? No, because this is 7 equals 1, which is not equal. What does that mean? 16 is not a solution. What does that mean? This whole equation is a no solution. Okay, that is my answer. This whole equation is a no solution. Now you may be wondering, you mean to tell me, Mr. Carlson, we went through that whole problem and there's no solution? Oh, I hate math. Oh. No solution is still a solution. Okay, it's still an answer. So relax your jitters here, okay? Because your math anxiety, don't let it get all like puffed up like my cat on like a rainy day. No need for that, all right? Don't get all puffed up. What this means is it's no solution, but that's still a solution. So good job. You found out that this equation doesn't have a solution. You should still be proud of that, right? So that's probably some of the harder ones that you'll see on the homework. So if you kind of understood that, that's great. If not, you can just go over it again. Now I'm going to go through this example, but I'm going to go through this a lot faster because I don't want this video to be very long. So this is the last example we're going to go through. And I want to see if you can kind of try to follow along as much as possible. Okay? What I'm going to do is I'm going to take one of these over to the other side. So what does that look like? That means it's going to look something like this. So 2x and then plus 3 equals. And then I'm going to have 3 minus radical x minus 7. I'm going to square both sides. So when I square both sides, it's going to look like this. 2x and then plus 3 equals. And then this is going to be 3 minus radical x minus 7. And then times 3 minus radical x minus 7. I'm going to FOIL it out, but I'm going to keep this left side just chilling. So 3 times 3 is 9. 3 times a negative radical x minus 7 is minus 3 times radical x minus 7. Exact same thing here on the inner side, in the inner term, so I'm going to just rewrite it. It's the exact same thing. 3 times negative radical x minus 7. And then when I get this, negative times a negative equals a positive, but since it's the exact same base, x minus 7, I'm just going to write x minus 7. No radicals needed. Let's start simplifying this. I can combine the negative 7 and then the 9, so that becomes negative 2. Negative 3 minus 3 is negative 6, and then radical x minus 7. Okay? Now this all gets transferred down, so let's start combining this stuff. I'm actually going to, at this point, I'm probably going to just, there's a couple ways you can do this. So let's try to solve it this way. I'm going to add the 2 over. So let's add the 2 over. This is 2x and then plus 5 equals negative 6. And then minus, actually no, sorry. This is going to be radical and then x minus 7. Okay? Awesome. Oh, wait, hold on. I just noticed right here, this is going to be a positive 2. 9 minus 7 is a positive 2. I subtracted over to equal 1. Silly goose. So let me get rid of that. This is equals 1. Sweet. So since that equals 1, I'm now going to do this. Recognize that I'm going to recognize I still have a plus x out here. So when I have a plus x, I'm actually going to subtract that over. So now what I have on the left side is just x plus 1 and then equals negative 6 and then radical x minus 7. So even me, it's a long problem, and this is probably one of the very few that you'll have on your homework. It's not going to be a lot of these on the homework at all, but it is kind of complicated. Make sure you keep track of your x's and everything else. So now that I have all this, I'm going to divide because I want to isolate the radical. I need to divide by negative 6. Divide by negative 6. Now, some of you may be thinking, holy junk, what is that? So I'm going to expand it over here, and so we can kind of see what's happening here. What I have is x plus 1 all over negative 6. equals, and then radical x minus 7. Now, when I get to this point, guys, it may look very, very confusing because you have a fraction, but you're going to do the exact same thing like normal. You're going to square both sides. That goes poofy. What I'm left with is x minus 7. Now, on this side, the squared goes to everything, the numerator and the denominator. So this squared actually goes to the whole of the numerator and the whole of the denominator. So it's what's x plus 1 squared? Well, it's going to look like this, x plus 1 squared, and then all over, negative 6 squared is 36. So I'm going to start foiling this out, but before I actually do that, I'm going to multiply by 36. So I'm going to get rid of this fraction because it is nasty. So what I'm going to do is multiply by 36. That goes poofy. I'm going to FOIL this out. I know I'm skipping steps here because I'm trying to go fast, but I'm going to FOIL this out on the numerator to be this. X plus 1 squared is x squared plus 2x plus 1. This equals 36x and then minus 252. So 36 times 7 is actually negative 252 because there's a negative there. Now what I'm going to do is I'm just going to start solving it like normal. Finally, okay? So now I'm going to subtract this stuff over. I have x squared and then minus 34x and then plus 253 because I'm going to add the 252 over, the negative 252 over, and I'm going to subtract that 36x over. This equals 0. Now, surprisingly, this is factorable, and I'm not going to show that right now, but it is. Factors of 253, what you actually get is x equals 23 and 11. Okay, so I'm going to skip that whole step because, again, you won't really see this kind of question on here. If you're following along and everything, that's fantastic. But notice I still need to check it, and I'm sorry to say after I checked both of them, none of them, they're neither a solution. So this is another no solution, which again is still a solution. Even saying that this question is a no solution is still a solution. So that's good. This is a rather hard question. I understand that. You're not going to see a lot of these on the homework, but I still wanted to kind of go through it to see what it would look like and see if you guys could follow along, okay? Pause the screen if you need to get that. Otherwise, I'm going to erase. Awesome. So really all we learned is how to solve radical equations and differing radical equations. There's a lot more I could have gone over and I wanted to go over, but for the sake of time, I just didn't. So what are you guys going to be doing today? You're just going to be solving radical equations. We will have an optional homework quiz tomorrow, but just do not forget about missing work in the meantime. You have a quiz that's going to be the Unit 2 test that's going to be this Friday. So do not procrastinate. Until next time, this is C Squared Mathematics. Be sure to like and subscribe. See ya.